Good day. Today we're going to be focusing on a couple of different topics. The first topic is going to be drive constraints and getting things set up to make a rack and a pinion move, which is a project that I use in my class. And so this video will help my students significantly on their current arbor press project uh, to create and make that arbor press move appropriately. So we're going to talk a little bit about how to create a keyway, and with that keyway, uh, develop the key that works with the spur gear, and then how to make the spur gear interact with the handle or a pin that the keyway is inserted to. And so it's going to be a fairly lengthy video overall, but I thought I'd get you started, and for my students, we're going to post these files in our learning management system, so that way you'll have access to the starting files, and that way it won't take you as long uh, to follow along. Unfortunately, if you're on YouTube, I'm not posting any of my IPT files, but basically the rack and pinion, or the rack and the spur gear, sorry, uh, those can be grabbed from uh, any number of sources, and the process of creating this interaction is consistent no matter what uh, uh, tool that you're using in terms of the spur and the rack. So first things first, we're going to show you the three items. We're going to have a base, and so I created the base with a notch that basically the rack is going to slide in. And then we have the spur gear, which is going to drive the rack itself. We need to create a pin that's going to go through the spur gear and interact with the spur gear keyway. And we're going to have to create a key that's going to mate to both the spur and the pin itself. So that's an important component of the whole aspect. You don't always want to rely on drawing information. What you want to rely is the actual object. So in this case, if we give you the spur gear, you want to use the keyway in the spur gear to create uh, the notch that's in the drive shaft, or in this case, the pin that will be helping drive the object. So the first thing that we need to do is we need to put all three of these into an assembly file so we can start assembling it, figuring out exactly what we need to work with. So we're just going to go ahead and create a brand new assembly. And we're going to go ahead and place the files. And so we're going to go ahead and place the base. And if I hold the control key down, I can place all three of these files at one time. Now I created a pin at one point, and this pin actually had, if you look at the Inventor 2015 video, the pin actually is part of the keyway. So we actually created a unique drive uh, keyway uh, onto the pin itself. So we're going to go ahead and add the rack and the spur all into the assembly file here. So I'm going to go ahead and zoom out, left mouse click, and we only need one of these. We don't need more. So we only have one of these particular files, and so we have three files. None of them are grounded in the assembly yet. And so grounding an object in an assembly is an important process because everything needs to move to that object. And so it'll be important for us to ground the base. And so to ground the base, we can right mouse click on the browser window and choose grounded. So now now the base does not move. However, the spur gear and the rack will both move, which is good, which is good. Okay, so let's go back to the home view, and uh, that'll work for our initial home view, and we'll work from there. So the next thing that we have to do is we need to create a pin. And a key for that pin. So magnifying the spur, we'll notice that that keyway is going to be what we're going to need to work with. So here's what we're going to do. So we're going to go ahead and create a new file, and this one's going to be the drive, or the shaft is what we'll call it, and then we'll cut a keyway in there and build a key that will mate with both the spur gear and the shaft itself. So we'll create, and we'll, as we mentioned, we'll call it shaft, and it's going to be under a specific file location, and I can put it anywhere I need to, and then choose OK. And I'm going to use the face of the spur as the starting surface of the shaft. And so then I'll put a sketch on the face of the spur on the XY plane. And so as you can see, we've got the spur gear, and this is now centered more or less on the spur gear because we chose the spur as that surface that we want to work with. So I'm going to project the geometry of the keyway and the pin location of the spur gear. And so we're going to create the shaft. I keep calling it a pin, but it's truly a shaft. And so creating the shaft, we're going to create a circle based on the center, and it's going to go out to the outer edge. Do we need to dimension it? We do not, because we just connected it. However, if you do want to put a dimension on it, you can. And this one says that it's going to over-constrain it, but that's okay. It'll just be a reference dimension. So the second thing that we have to do with this shaft is we need to cut in a keyway. And so we could do one of two things. Actually, I'm going to use a technique which is going to mirror this keyway into the shaft. And then we'll utilize that as the actual drive. Or I can just use the line command, connect to the end of the current keyway, bring it across, and you saw how I highlighted to get the distance, and then just connect it. So I could do that too, and then I still have to put a dimension in though of the overall distance of the keyway. And so if we're going to set a keyway, this is pretty darn small at this point. And if I make it much larger, if I go 1/8 of an inch, we'll have a little bit of a drive, but we'll have most of it in the shaft itself. So I just made this 1/8 of an inch, and again, I can say OK, and I can then adjust this dimension so it's not in the way of the other. So you can use the existing geometry and you can mirror it. And if I was to mirror that, what I would have done is I would have created a line across, stopped that line, highlighted it, and made it a construction line. And so making that line a construction line won't use it in the geometry development. And then I could take and then mirror, use the mirror tool to mirror these three pieces of geometry and have an equal distance on both sides. That would work also. The big thing is being able to set up a construction line if you need it to help structure what we need. I can leave the construction line in or I can delete it. I'll just select it, hit the delete key, and get rid of that line. Okay, so now at this point, I need to trim this top part out because it's part of the circle that I don't need, but I do need to now extrude this. And we're going to need to extrude this particular object. We'll extrude it 3.5 inches. So we'll finish the sketch, choose extrude. Doesn't know exactly what to extrude, so I'll select the object to extrude, which is the created surface. Now again, if the object does not automatically get selected, you need to select that profile. You need to go and actually select that object. And if it doesn't select properly, or if it gives you an error that it's uh, an open connection, then there is always this little red cross up at the top, or it will show up on the extrude command, usually down here in the bottom. And you can use that to help diagnose what the potential issue might be. And usually it's an open loop. You didn't get all the dots connected when you created the object. So right now we'll go ahead and extrude this 3 inches. And that should be enough. And if it isn't, we can always go back and update it. So we now created the shaft itself, and we'll return out. So now we have to create another part, and that's going to be the key for the keyway. And what's nice is that I can use the end of the shaft, or I can go back and use the spur surface as the basis to create that key, or the key itself. So we're going to create a new object. We're going to call it key. And with the key, I'm going to go ahead and just use the spur gear again as that surface. And we'll create a sketch on that surface again on that XY plane. So now I need to create a key that is the shape of the object. However, if I do that, I can project the geometry, use the project geometry tool here, and I can project all the geometry to the surface. The deal is, though, when we constrain all this, this needs to be totally at top dead center to be accurate for constraint purposes. And we know it'll constrain because we created the geometry from the original spur gear information. If we create the key slightly smaller, which typically is the case because you want a sliding fit with the key, the problem is constraining that slightly smaller key. We can constrain it to one edge and one surface only. Don't try to constrain it across 2 surfaces. So you'll constrain it to one surface and do a flush constraint. And so you'll have 2 mates and a flush to accomplish that constraint. But don't try to constrain to the opposite surface, because more than likely that key is going to be slightly smaller just for that sliding fit. So I can create a rectangle, and this one happen to be the exact size that we need. Do we need to dimension it? Not really, but it's always a good practice, and it's going to tell me that I don't need to because I picked the endpoints and so forth. So now I'm going to go ahead and finish the sketch and extrude the key. And so the key is going to extrude, and we'll just extrude it 1 inch, or 1.25. So it's a 1.25 inches. Now you'll notice that in the browser that we've been building the shaft and the key, we've got the little icon that indicates that it's adaptive. And what's nice about the adaptivity is that if we were to change the spur gear, that it would automatically change the size of the shaft and the keyway. What's a deterrent about the adaptivity is that it also puts a flush constraint on here, and that will end up taking the flush constraint off in just a minute. We'll show you what that looks like. So under the shaft and or the key, you'll notice that we have a flush constraint for the key and now a flush constraint for the shaft. We'll have to delete these before we can go forward with constraining the object. So whenever you create an object inside of an assembly where the object is based on a surface of another object, you're going to get this flush constraint. And so we'll just delete these 2 flush constraints. And what that will do is this will allow our shaft and the keyway to orient itself as needed. But it's still based on the shaft itself. There's still a linkage to the shaft itself because it's adaptive. If we turn off the adaptivity, which you can do by unchecking the adaptive, and once you uncheck it, you can't add it back in again. It goes away. And so since it's adaptive, it's not going to change its position. So I had a microphone problem, and so we're going to reshoot part of the second half of this video. And so what we left off at was the interaction between the spur gear, the shaft, and the keyway. And so what we've discovered is that if you have adaptive products, the products follow the object that it's adaptive to. If we take the adaptivity off the keyway, we can turn adaptivity on and off. And so the adaptivity can return by turning it back on and off. Just right mouse click in the browser and we'll turn the adaptivity off of the key. And so the key now is a flexible separate project. If we turn it back on, it would snap back into the slot of the shaft. The other component that we're going to mention is the ability to do what is known as a free rotate or a free move. If you right mouse click on an object, one of the options is to have free move and free rotate. Well, free rotate allows you to orient the object the direction that you would like. And so I actually want the threaded part of the rack to be pointed towards me. And so when I go and create the constraints on the rack, it's in the proper direction already. So using the right mouse click on the object and using the free move or the free rotate or the letter V and the letter G if you want to use key codes, keyboard codes, you can do that too. And so that just makes it a little bit easier to pre-position and orient the objects. So let's start to put this together. We're going to go ahead and put the rack in place first. And we're going to use the constraint and the mate constraint. And as you know the rule, 2 flushes and a mate or 2 mates and a flush typically get the job done. So we're going to go ahead and mate the top surface of the slot here to the bottom of the rack. And so using the view cube, we'll spin it around and we'll lock that into the object. And we'll spin this back around. So again, the orientation of the object isn't right, but it is now on that surface. If I cancel out of the constraint command, I can grab the object and move it and continue the constraint command again. This time we're going to go ahead and constrain the side of this object to the side of the base, this little surface there. And that pretty much now orients the object. And I can apply that and choose cancel. So this object still moves, but it doesn't, it just slides up and back in this slot like it's supposed to. And that's the idea. We're going to keep that last degree of freedom or that last direction of freedom so we have that for the actual movement. In terms of the shaft and the spur gear, we're going to go ahead and orient the shaft into the hole first. Then we're going to use the constraint of a center line on the shaft and the center line on the hole and apply those two. And again, once I hit cancel, I can then move the shaft and move the spur gear into position. And notice that the keyway is still not connected. So I'm going to go ahead and put the spur gear about in the right orientation here. We can look on the right view here, and that's the advantage, is that I can take and position this. And with the shaft, what we're going to do is flush the surface of the shaft to the spur gear. And so we'll choose constrain and flush and the surface of the shaft to the surface of the spur gear and apply that. And so now those are connected. And we'll choose cancel. So now those two are connected, but the problem that I have is that part of the shaft sticks out on the other end, and right now it's still flexible. Again, it just can move in and out. There's no constraint. And so we're going to need to apply another constraint to this object. And most people would take and apply the constraint to the spur gear and make the spur gear flush to the rack. That is an option, and we couldn't try that, but it may also limit the movement of the spur gear. So I can't guarantee that this is the best way to go. What I would prefer to do is to take a measurement from the surface of the base to the face of the shaft and then put in a flush constraint with an offset on the shaft itself. And so I'll prefer to do that option. It's a little bit more work, but it also allows us to use the inspect um, ribbon, choosing distance, and we want the distance from the surface to the face of the shaft, and it's 1.238. It's about 1.235 is the or 2375 is the distance or the actual distance, but the 238 is a rounded number. So what we'll do is we'll then go back to the Assemble tab, choose Constraint, choose Flush, pick the two surfaces, and we're going to go ahead and type in 1.2375. And so we're going to say that we want the distance between the two surfaces to remain that offset of 1.2375. Hit OK and choose Cancel. Now you can see that I can spin the spur gear, but it doesn't move in and out and doesn't change the position of it. It is located on the rack. And currently the rack and the spur gear are separate objects. Now the shaft and the spur gear are connected. And that's because of the adaptivity that's been created. So now what we're going to do is put the keyway into the shaft and the spur gear. So we're going to go ahead and constrain. Now the keyway is equal distance on both sides, so we're going to pick one of the long surfaces here, and we're going to go ahead and set that as a keyway in that surface itself. Hit cancel. I can still grab the keyway and move it out because it's only got one constraint on it currently, which is good because I still need to orient the keyway. And so the other constraint that I need to place on the keyway is the bottom of the keyway to the bottom of the slot, the keyway slot. So the bottom of the key to the bottom of the keyway. And so we're going to constrain a mate constraint to that. And so we'll pick the bottom of the keyway and flip this around, and the bottom of the key, and we'll apply it and choose cancel. So again, now the keyway is still there. I can still move the keyway in and out, but you can see how it's now connected. And so the last constraint that we apply to the keyway here is the flush constraint, and flush this against either the shaft or the spur. And so we'll choose constraint, flush the end of the keyway to the end of the spur, and it connects and applies. And we'll cancel it. So now the spur gear, the keyway, and the shaft are all connected. And again, if you remember with creating it, you want to create the key either the exact same size as the keyway and the key slot in the object for the drive, or if it is created slightly smaller, then you need to constrain it just to one surface. And so if you try to constrain it to both the spur gear and the shaft, it will fail. It will fail. Okay, so now that we've got everything oriented, let's go ahead and make this work. And to make this work, we're going to use a tool, a constraint tool, that sets up and orients the rotation and translation is what it's called. And so under constraints, we have motion constraints, and we have a linear to circular motion called rotation translation. So the whole idea is that we're transferring rotational movement to linear movement, and there's a distance involved. And this distance is a function of the pitch diameter of the spur gear. Or it would be in this case, the pitch diameter is the distance between both teeth, and that's the interactive mating location of the gear teeth. It's that diameter times 3.14 pi. So in this case, the distance is 3.14. Now, we can either choose the spur gear as the rotation translation, or we can choose the shaft. Well, it depends on what we really want to drive. Do we want the spur gear to drive this, or do we want the shaft? Well, theoretically, if we choose the spur gear, it may or may not work. We can test it and see what happens. If not, we can always redo it. It's not a problem. So let's try the spur gear. And the second component is a linear position. Well, I'm going to cancel this because I need to move the um, rack out a little bit. The rack was in the surface, but I need to get this bottom edge to select that. So we'll again start the constraint, go to motion, rotation translation, distance is 3.14, which is a 1-inch spur gear pitch diameter. And then I'll pick the side of the spur gear and the bottom edge, not the surface. So I'm picking an edge, and you can see, it's hard to see, but there's an actual arrow on the edge pointing in the same direction as that threaded hole. And so we want to use the edge vector. Once it's applied, and I choose OK, I should be able to move the rack, and the spur gear should change and should rotate. If it doesn't, and it just stands there, then we're probably going to have to use the shaft as our rotation translation connector. So we'll go ahead and hit cancel. Let's see what happens here. Hey, it works. So sometimes it does work with the object. Other times, if it doesn't work, then try the other circular object, because it only works with circular objects. So the gear worked fine, and the shaft will also work. I tested that a little bit earlier. But here's the problem. As I move the rack, the spur gear moves in the opposite direction. So we have to edit the rotation translation constraint. So we right mouse click on the browser bar and edit the constraint and change the solution. And so once we change the solution, the rack and the spur gear now mesh better. But it's not perfect. If we take a look straight on, you can see that the teeth are really not meshing well. So what do we need to do? We need to suppress the rotation translation, adjust the teeth. So again, it's back to the browser, right mouse click on rotation translation, suppress it, adjust the position of the rack or the position of the spur gear so that way the teeth interact appropriately, and then unsuppress it. Now, as it moves, it's consistent and it works really well. Okay, so now you've got the movement. We're 2/3 of the way there. We've now connected all the components. We have the appropriate movement. Now, what happens if it doesn't move? Well, if it doesn't move, and it's frozen, what we have to do is look at what constraints do we have that might make it freeze. And if it was moving freely all the way up to the rotation translation, then instead of the spur gear, try the shaft. If it doesn't move after you apply a specific dimension or specific constraint, then you know that that's the culprit of the movement. So don't go putting a bunch of constraints. Test it every so often to see if things still move. And once you put the rotation translation, they'll mesh. So now the last part of this presentation is all about how to make this work and work within the Inventor software to actually control how far this rack and the spur gear turn. And this is called a drive constraint. Okay, it's called a drive constraint. And so the constraint that we're going to apply, and most of the times the constraint that we do apply is a constraint called an angle constraint. And so we're going to have to make an angle between two flat surfaces. And so the easiest flat surface to do this with is the shaft. So you've got a keyway in the shaft, and I can either use the bottom of the keyway and the top of the object, or I could use the side of the keyway and the side of the object. I could theoretically use the side of the keyway and the top of the object too. But it has to be two flat surfaces. It will not work with a rounded surface. So I'm going to choose an angle constraint. And one of the things that we'll notice, and I'm going to back this out just a little bit, I'm going to zoom in and pick the first surface here. And I'm going to pick this surface here, which is the side of the keyway. And it doesn't really matter. I can pick any one of the three surfaces, but I'm going to pick the side of the keyway. I'm going to back out a little bit So that way you can see what's going to happen. When I pick the surface, the side surface here, we're going to basically turn this 0, 0. So that keyway is going to rotate till it's vertical. And that also means that it's going to rotate the spur gear, which also means it's going to move the rack. So it's in the proper orientation of top dead center, vertical, and so that way the keyway slot is going to be vertical in the position. And when I choose my solution, I actually want a directed angle. And so if you pick the vectoring angle or the undirected angle, it won't work. You must choose the directed angle option. We'll leave the angle at 0. And when we apply it, watch what happens over with the spur gear in the rack. So I'm going to hit apply. The spur gear and the rack have moved. Now this is at top dead center because it's vertical against this vertical. And that's also the key to tell you that this actually all now connects and works, because it moved and adjusted itself, even though it was just a fraction of a rotation. This also means that we no longer can just grab the end and turn it. The only way we can make this move now is actually going in. Did I just cancel that? Is going in. Let's see if there. Nope, there is an angle constraint on the. Here's the deal. I don't have the shaft expanded, so there's an angle constraint on the shaft and the base. So I have to go into the angle constraint that we just applied and choose drive. And so this will drive that angle constraint to the proper angle. So we'll pick drive, and we get a really cool dialog box. It kind of looks like a VCR or a DVD player kind of thing. A VCR. Ooh, I don't even make those anymore. But we start at 0, which is currently where we're at, and it's going to go to 10 degrees. But we'll set this up to about, we'll go 80 degrees so we can see what happens. So we're going to go ahead and move this forward. So 80 degrees actually moved it backwards. And so we might go 90. And we'll continue to move that along now. Let's do maybe 110, another 20 degrees, and maybe 120 is going to be the magic number here. Yeah, so about 120 degrees we can look here. It's not quite. We could probably do a 130 on the rotational angle here and see how this goes. Almost there, 140. And so what we're doing is we're just kind of tweaking this so that way it goes to the maximum position before it crashes, and we don't want it to crash. If we hit the back button, the reverse button, it's going to go ahead and move it back to the 0 spot, which is where we were. So now if I want this to move forward, I'm going to have to put a negative number in here. So let's go with negative 90, and we'll continue to hit reverse. And negative 90 gets me there, so let's do negative 120. And I'll hit reverse. And 120 is pretty close. Let's do a negative 140 and see what happens. Negative 140 is close, so it's going to be closer to negative 160. And if I go too far, yep, it crashed. So I'm going to have to go like a negative 150. And I have to use the numbers to make sure. And I can pause it, and I can hit reverse and try the negative 150. So negative 150 is going to work well. So it's positive 140 to negative 150. Let's kind of angle this out a little bit so you can see what it's doing. And I'll just hit the play button back here, and it's going to go all the way to the other side. Boom, stops. And then we can hit the reverse button, and it will go all the way to that side. So that's the true movement of this rack. That's as far as the rack can move. And so we're driving this constraint. This is going to become a big player when we actually do a live or a true full animation of movement. We actually use this constraint to actually make the animation work. So it's not, and by the way, we can record this as a simple recording to make that operate. So that's pretty much what's going on with the rack, the spur, the shaft, and the ability to make a key drive everything, or in this case, the shaft actually drives the spur, which drives the rack. So hopefully this was informational. And if you're in my class, you know how to contact me. And if you're not in my class, you can always post on YouTube, and I might get to it, but typically I unfortunately don't have a lot of time to do posts and reviews and so forth. But hopefully you find this educational. Have a great day.